Sometimes, like in example 7, it's not as straightforward as the example before. So they want us to take the function f of x, which is 3x squared minus 4x plus 2. And they want us to evaluate it at x equals 1.05, then 1.15, then 1.25, and keep on doing this till we reach 2.95. Those are the x values. They want us to calculate f at those x values, then give the sum. So they want us to get all the sum of f of x for all those x values. So again, as if you want to do f of 1.05, f of 1.15, f of 1.25, and you keep doing this till you reach f of 2.95. When you get all the answers, you add them to each other and give what the final answer is. This is what they want. Sum the values of f of x evaluated at those x's that we have over here. Again, doing this way is too time consuming, because what helps us in knowing that it's time consuming, see, if x was random, the only way we can do it is evaluate at x. But what is very simple about this problem is we notice there is a pattern. What is the pattern? The pattern is that the difference between the x's is always equal to how much? 0.1. You're right. You go from 1.05 plus 0.1, 1.15, plus 0.1, 1.25, then 1.35, 1.45, you keep on doing this. 1.05, it becomes 1.15, then 1.25, 1.35, 1.45, 1.55. You keep on doing this. 1.65, 1.75, 1.85, 1.95, 2.05, 2.15, 2.25, 2.35, 2.45. Do you imagine? 2.55, 2.65, 2.75, 2.85 till you reach 2.95. All of these are the values that we are aiming at, substituting in the function, evaluating the function, then adding the answers. It can take us ages. Yani, how many numbers do we have over here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 numbers. When I notice a pattern between those numbers, the moment I look at the pattern of the x values, I notice that the difference between those x values is a constant. It's equal to 0.1. Right? So I can create now a formula where I add the first 0.1, get this. Then I add the second 0.1, I get this. Then I add the third 0.1 to get this. The 20th 0.1 that I will add it will give me this. See, I can name my AIs, those x's that I have. I notice a pattern. What is the first number that we got? 1.05. To what do we add 0.1 to get 1.05? We start at 0.95 and we add 0.1 times I. When I is 1, you add the first 0.1. 0.95 plus 0.1, it gives you 1.05, the first number. When I is 2, you add how many 0.1s? 2 0.1s. 0.95. The first 0.1 gave me 1.05. When I add the second 0.1, I get 1.15. Then 3. I need to add 3 0.1s to 0.95. The first 0.1 gave me this. When I added the second, it gives me this. When I add the third, it will give me 1.25. How many times do I need to do this? I need to do it from 1 to 20. At the 20th one, 0.1 times 20 is 2. 2 plus 0.95, it gives me 2.95, the answer of the last x value that I want to have. And then what is the summation I'm looking for? I'm looking at finding f at those AIs from I equals 1 to 20. From 0.95 plus 0.1i. What is f? F is 3x squared minus 4x plus 2. So it takes whatever x we have, 3x squared minus 4x plus 2. This is the f What do I want to do with all of these? I want to add them from 1 to 20. What I do next is I simplify algebraically. I simplify the inside. I get 3. 0.95 squared is equal to 0.9025 plus 2 times 0.95 times 0.1, you get 0.19 I plus 0.1 squared I squared minus 4 times 0.95 is 3.8 minus 4 times 0.1, 0.4i plus 2. Simplifying and adding the terms with I squared alone, with I alone and the constants alone. 3 times 0.9025 is 2.7075 plus 0.19 times 3, 0.57i plus 0.03i squared minus 3.8 minus 0.4i plus 2. This gives me summation of, let's add the constants first. This plus this plus this, we get 2.7075 minus 3.8 plus 2. The answer is 0.9075. Then whatever has I together, this gives me 0.17i. The one that has I squared together, I want to add all of those from I equal 1 to 20. See, this is simple because when I have addition, I do each one alone. To sum a constant, you just multiply the constant by n, which is 20. 0.17 is a constant, you keep it. To sum I, you do n, which is 20 times n plus 1 over 2 plus 0.03 is another constant. Then you sum what? I squared from 1 to 20. What's the sum of I squared from 1 to 20? It's n plus 1, 2n plus 1 over 6. And then what will the total be? This times 20 plus 0.17 times 20 times 21 divided by 2 plus 0.03 times 20 times 21 times 41 divided by 6. The answer will be in total 139.95. Good luck with doing it the other way, which is finding the function value at each one of these and then adding the answers. صح, we took a long time to do this, but this is just algebra. It's not just a calculation and you add them. So what is the first step? You figure out the pattern between the x values. We noticed that the x values, what is the pattern? We are adding 0.1 every time. So the difference between them is 0.1. Then I generate my AIs. What do my AIs look like? Many students think that the first one should be 1.05. No, the first one is when we add 0.1 the first time. To what number do we add 0.1 to get 1.05? So we do 1.05 minus 0.1. You get, it is 0.95. So 0.95 is your starting number plus 0.1i, where I starts at 1, finishes at 20. Then when you have the shape of AI, you substitute this AI in the function that they gave you, which is 3x squared minus 4x plus 2. Then we expand it, we add the constants to each other, the I value, the I similar term to each other and I squared to each other. Then we do the summation of each, remembering that the sum of a constant is the constant times n. The sum of a constant times I, the constant, you throw it outside of the sum and you add I 20 times, which means you get 20 times 21 over 2. Plus 0.03 is a constant, you throw it out, you do summation of I squared from 1 to 20. It's equal to n plus 1, 2n plus 1 over 6, which gives you the total value that we have over here. This is very important, and this is, you need to practice this. You cannot miss any practicing of this. Please, there is part which is called mathematical induction. We do not do mathematical induction in this section. We do not prove anything using mathematical induction, so I don't want you to worry about that at all. The only things you're responsible for in this lesson is how to get basic sums using the formula that I just announced. And that's it. You don't need to do mathematical induction or any mathematical proofs. Solve as many exercises as you can on this, and that will be your lesson for today, Sunday. The total is only about 43 minutes, but because I've been taking extra time last week, so now I thought the lecture would be just a little bit less than 1 hour. All right, thank you.